Today I will test the performance of these three scars. This scar that I've just created, a 6-degree bearing with lots of potting. A Blastertech Mark II scar string, and another prototype of mine that I've made earlier that has 20-degree bearings. The three darts that I'll be shooting are worker gentries that are symmetrical. Symmetrical because I want the center of pressure to remain almost the same between these three darts, so there'll be a fair comparison. It's a brand new darts. So now I will first start with the Blastertech Mark II, this, and then the new scar. I am happy that the research paid off, as you might observe the difference in dart stability between these three devices. Starting from the worst, the over-angled 20 degrees. Dart flight was overly stabilized and caused the tail to swing out from centrifugal forces. This results in a high angle of attack, leading to increased cross-sectional area and hence drag. This would mean reduced range and accuracy. Middle performer was the Blastertech Mark II, turned to 90 degrees. Dart flight was stable, however it was still overly stable, seeing that a spiraling tail pattern was still present. Darts came out at an angle for both these two devices. Best was from the research-based design. Dart's exit was nearly straight, which is a sign of near perfect stabilization. While no spiraling pattern can be observed, if you zoom in you can see the tail oscillating in 120 degree steps. This proves that the dart is spinning and that the gyroscopic stability is not too strong, that it prevents the natural stability of the dart from taking over. What do I mean by natural stability? Because of how foam darts are designed, the center of gravity lies ahead of the center of pressure. Fluid forces act on the center of pressure to steer the dart into the wind. As such, darts are actually naturally stable. An overly stabilized profile would spin the tail out and increase drag. If you would compare a spinning tail versus an oscillating one, the total average cross-sectional area would be more for the overly stable one. Of course, a lot of that depends on the symmetricity of the darts, including external forces such as wind. More accuracy tests have to be performed in order to really determine the effectiveness of this engineered design. There was a lot of work done to achieve this. The straightness of exiting darts depend greatly on smoothing the turbulent expanding air, aided by elliptical profiles on all exits. Concentricity is also important with a compact 3-jaw clamp and self-centering 2-point contact on the long axis, resulting in near perfect straightness as the locating points are not over constrained. Tapered bearing crush, entry and exit also eases foam compression and decompression, reducing any unwanted side forces. There isn't a name for this device yet. It should no longer be called a SCAR because, as the name is truncated from string-based centering and rifling, this no longer uses strings. If anyone has ideas, feel free to write it in the comments. I may take up inspiration from multiple sources to create the most suitable name for it. Lastly, if anyone has further analysis on the flight profile of the darts in the video, let me know for the benefit of the Nerf community.